Sir, am I audible, sir? Hello, sir.
Yes, you are audible now.
Yes, sir.
I thought I got a notification that you left the class.
Sir, no, sir. I am in class only, sir. Actually, sir, I have joined in my laptop that has been structured. That's why I joined in mobile, sir. That's all happened.
Okay, that
It
might
got
be the
structured
issue.
and it's not working. That's why I joined from mobile, sir.
Okay, fine. Okay, now. So let us start from electrostatics. So electrostatics you have studied. Hello. Yes, again I am not able
Yes,
to
sir.
hear you.
Sir, now am I audible,
Yes,
sir?
yes.
Yes.
So electrostatics, have you studied or you want to take down the notes as well?
Sir, take to the notes, sir, from basic to advanced. I have not studied it.
Okay, fine. So for your board is also Andhra board, na? Fine. Fine. So we shall see from the basics of electromagnetism. Okay. So what
Yes,
is
sir.
electrostatics? Electrostatics. Okay. Wait a minute. Your board is fine. This is of Chanakya as well, but fine. So electromagnetism. What is electromagnetism? Electromagnetism is that branch of physics in which we study about electricity, electric charges, magnetism, and their effects. What are their effects? Okay. Now, in this larger branch of physics, electrostatics is that part which deals with the charges at rest. Do you understand charges at rest? It means what? It means the charges are not moving. They are not going anywhere. Okay. This is what we mean by charges at rest. Just wait a minute. Uh, Fine. So we are going to start with electrostatics. Electrostatics. So first of all, in electrostatics, we are going to study about the charges. About what? Charges. Now, what are these charges? Historically speaking, these charges, before the discovery of charges, humans came in contact with the flow of charge. Can you tell me what was that flow of charge with which humans came in contact?
So you can say thundering like that we can say. So.
Huh?
Thundering in the sky we can say. So.
Thundering in the sky, thundering in the sky. Similarly, electric eel is there. Electric eel is there. It's a biological organism, and that fish, it can give up to 100-volt shock in case any predator wants to attack that fish. Okay, it can give a shock up to 100 volts. That was called in Egypt thunderer of Nile. So there also it was giving electric shock. So from there also humans were in contact with these charges. Similarly, in India also, we have found a book called in South only that book was discovered. Its name was Agastya Samhita. Agastya Samhita. Its name was, and in that book, construction of a battery is given. It is written in Sanskrit, and construction of a battery is given in that book. Like when you will take a copper plate and keep it in an earthen pot and cover it with copper sulfate with some moist sawdust, and then amalgamated zinc, mercury and zinc we will deposit over it. It will give us power, and that power is called Maitra Varuni Shakti in that book. That is nothing but electricity. And another line of that book, it tells us that 100 such pots, 100 such earthen pots, when they are combined together, they will give us enough oxygen, enough energy to water, break water into pranavayu. Pranavayu means oxygen. Nobody knows how they knew all these things and how these things were written, because that is authentic ancient book. But electricity is mentioned in that, and even this electrolysis of water, it is also mentioned there. Now later in 18th century, with extensive research in electricity by Benjamin Franklin, what did Benjamin Franklin do? He just flew a kite with a small iron key hung over it. So several of the experiments Benjamin Franklin did, and then galvanic cells were made. Then voltaic cells were made by Alessandro Volta, and then from Oersted, H.C. Oersted, Oersted performed several experiments, and he first of all indicated that magnetism and electricity they are interconnected. From that point, electric generators electric generators were developed, and then Michael Faraday developed electric motor, and with the electric motor a new era of electromagnetism it started. So here all this study, whatever we are going to study in this chapter, all these things, they are nothing but electromagnetism. Electromagnetism, and this electromagnetism is having two parts. One is electrostatics, and another is electrodynamics. Next is electrodynamics. Now, what is electrostatics? Electrostatic is a study of charges at rest. Electrostatics is a study of charges at rest. And electrodynamics is what? A study of charges in motion. A study of charges in motion. Like whenever the charges are in motion, what do we call that? We call it flow of electric charge, or we can say electric charges are flowing. Like water is flowing. Flowing water is called current of water. Similarly, here we will call it current of electrons, means electric current. And if electric current is flowing, then it is having several other effects also which accompanies it. That is magnetism. Magnetism. Next is electromagnetic induction, EMI, alternating current, electromagnetic waves. All these are part of electrodynamics. Okay. Now let us start with electrostatics. Electrostatics deals with the study of charges at rest. Study of charges. Now, what do we study? Charges at rest. We will do the study of forces. Study of forces or fields and potentials arising from static charges. Arising from static charges. Okay, this is the electrostatics. Now, what is the electric charge? Can you define electric charge? Yes, Hemant. What is an electric charge?
It's a property of a body like mass, like that we can say.
Means if I am having a mass, which I certainly do, does it mean I am also having charge with me? Because you said it's property of mass.
I mean, yes, we can say no, sir, because electrons are there in the body.
Electrons are there in body, so electrons are everywhere. In air also electrons are there. In water also electrons are there. Wood also electrons are there. Plastic also and everywhere electrons are there. So how can we define charge?
Yes, sir, yeah.
Yes, it's correct. Charge is a property. But property of what? Whose property it is? If it is a property of mass, then everywhere it should be present. But everywhere when we are not seeing the effect of charge, mass is everywhere, molecules are everywhere. It means electrons are everywhere, but we are not seeing their specific effects.
I mean, when
Why?
losing or gaining, like that.
Yes, very good. Why we are not seeing the effect? Because charge on a whole is uh, nullified because of the presence of protons. Because of the presence of protons. Okay. So, hello, hello. Yeah, am I audible? What happened?
Sir, nothing, sir.
Fine, fine, fine. So, charge is what? Write down. Charge is an intrinsic property. What do you mean by intrinsic now? Charge is an intrinsic property. Property of what? Intrinsic property of elementary particles. Now, what do you mean by intrinsic? Intrinsic means inner, natural and inner, which is already present inside the body. That is called intrinsic. Like heart of humans is intrinsically present inside their chest. Is it not? Yes. It is by nature. It is always there inside the body.
I mean, it's
Getting my
inner
point?
the body, we can say. Intrinsic means
Yes, yes.
inner the body, sir.
Inner the body, inside the body, it is already present. Always it is present. Body will not exist without that thing. So charge is also an intrinsic property of what? Of matter? No. Of elementary particles. What do you mean by elementary particles? Elementary particles means basic building blocks from which
Okay.
all the matters are formed. Now, what are those
Yes.
basic building blocks? Those basic building blocks are electrons and protons.
So, but we say that atoms are the basic building block because we cannot isolate electrons and protons.
No, we can isolate. Protons are always inside a nucleus. Okay, electrons are outside of the nucleus, so we can obviously do so. What do you think nuclear reaction is? What is happening in nuclear reaction? Same thing is happening. We are isolating them.
Yes,
Getting it? Yes,
yes, I get
protons
it.
change itself to electrons and uh, positron. Neutrons will change into electron and positron and antineutrino. Okay, these things we will study in modern physics later. Now, so charge is also an intrinsic property of elementary particles like electrons and protons. Okay, it is denoted by capital Q. Again now, see, I just told you that before charge, humans were able to discover about electric current. First, humans discovered about electric current, and later they came to know about charge. Got it? Later, humans discovered about charge. Getting my point? So that's why if you remember the dimensional analysis, then according to that, charge is called a derived physical quantity. Charge is a derived physical quantity and is measured in coulombs. And is measured in coulombs. In practice, we use very small charge such as microcoulombs, millicoulombs, or nanocoulombs. Okay. Now, CGS unit of charge is also there. CGS unit of charge is ESU. It is called as electrostatic unit. Electrostatic unit. Okay. 1 coulomb is equals to 3 into 10 to the power 9 ESU of charge. ESU of चार्ज की जगह एक और है इसका 3 into 10 to the power 9 stat coulombs or 3 into 10 to the power 9 Franklin. Franklin is denoted by FR. Okay. So all these are nothing but 1 coulomb. Next is EMU. Another unit is EMU. It is nothing but electromagnetic unit. Electromagnetic unit. This electromagnetic unit is also called as absolute coulomb. AB C capital. 1 coulomb is equals to 1 upon 10 absolute coulombs. Remember that. Similarly, some practical units are also there. Practical unit is 1 ampere hour.
Practical unit means what? So we can say.
Practical unit means very large units, like while dealing with heavy transformers or while dealing with charge is flowing through the thunderstorm, okay, practically which we see in nature,
Very large units. Like,
very large. Yes. So
yes, sir.
ampere hour is 3600 coulombs. Similarly, Faraday, 1 Faraday, it is 96500 coulomb. Okay, got it? Taken down?
Sir, copy it, sir.
Now, now, properties of charge. What are the properties of charge? First of all, charge is a scalar quantity. Now, what do you mean by scalar quantity? Scalar quantity means it does not have any direction. You can take it to east, west, north, south in any direction, but it will not change. Got it?
Yes, sir, got it.
Means it will be directly added up. It will not follow vector formula of addition. Okay. It will be added up algebraically. Next is charges are of two types, positive charge and negative charge. Positive charge is proton, and negative charge is electron. Got it?
I got it, sir. Yes, sir.
Next is like charges repel each other and unlike charges attract each other. Written down? You know all these properties. Next property is charge is always associated with mass. Charge is always associated with mass. It means what? What does it mean? It means that charge cannot exist without mass. Mass can exist without charge, but charge cannot exist without mass. Got it?
Sir,
Mass of
got it.
electron and mass of proton. Means whenever electrons and protons will be transferred, electrons and protons cannot transfer, but electrons can transfer. Okay. So whenever the electrons are going to transfer from one point to another point, then there will always be a transfer of mass. Mass will always be transferred. Okay. Fifth point, charge is always conserved. What do you mean by the conservation of charge? Yes, Iman. Generally, the conservation of charge, students get confused as conservation of energy, but it is not the conservation of energy. It is not the conservation of energy. What is conservation of energy? Conservation, yes, what is conservation of energy? Am I audible?
Sir, sir, you're audible, sir. Sir.
Yes, what is conservation of energy then?
So we can say energy. We can say energy cannot be created nor destroyed, only converted from one
Yes.
point.
Then what should be the conservation of charge?
Charge
Generally,
is neither created nor destroyed.
be destroyed. Generally, yes, generally we think that this is the conservation of energy, but it is not so. This is wrong. This is absolutely wrong for charge, because charges can be created and they can be destroyed. Okay, they can be created and can be destroyed. So what does it mean when we say charge is conserved? It means that whenever a system is isolated, then in an isolated system, total charge will remain same. Total charge of the system will remain same. There will be no change on the charges till the object is isolated. Till the object is isolated.
That means if an object is isolated, then the charge will be constant. We can say also.
Yes, charge will be constant. This is the conservation of charge. Charges can be created and can be destroyed in nuclear reaction. Electron plus positron, it gives us photon. Photon is what? Light. So this is nothing but annihilation of matter. Got it?
Yeah.
Write it down. Taken down.
It's a coughing, so 1 minute.
Fine.
So can you say second point, sir? Can you say this?
Second point is charges can be created and destroyed.
So no, so that charges are of two types. That point can you show, sir?
Okay, okay, okay.
Yes, to charge. Sir, copy it, sir.
Copy. Now, next is quantization of charge. What do you mean by quantization of charge? Yes, by quantization of charge, we mean that charge always exists in packets. Charge always exists in packets, and these packets are called quanta. Okay. So, quanta of charge is nothing but an electron. Electron is the smallest unit of charge which cannot be divided further. This cannot be divided further. Okay. So, this is the fundamental unit of charge. Quanta is nothing but the fundamental unit of charge. Okay. Now, what is the why we are taking fundamental unit of charge as electron? Because isolated means the smallest charge which is possible in nature is nothing but charge because of an electron. Getting it? Hello, am I audible?
Sir, you're audible, sir. Sir means charge exists in electrons or in quanta, sir. I'm not getting this point.
Means quanta of charge is electron. Quanta is what? The smallest packet of charge which is possible. Smallest packet of charge which is possible. That is called quanta of charge. So that quanta of charge is nothing but electron. It means whenever I'm going to charge a body, then I can transfer it one electron, two electron, three electrons. But I cannot transfer half a electron because an electron is a quanta and it will, quanta means a quantity. It will not go decreased or increase. 1.4 electrons or 0.3 electrons I cannot transfer. I can transfer only one electron full. Getting my point?
Yes, sir, getting, sir. So that quanta
It
is called
means
as a electron, we can say.
quanta of charge, quantization is means charge exists in form of packets. It is always integral multiple, integral packets. Packets, why are we using packets? Because if you are saying that this is a packet, packet cannot be divided further. Like in a packet, we have filled some groundnuts and that packet is sealed now. Now we cannot take half peanuts from that packet and pay for the bill. This is not possible. We have to buy full packet. Getting my point? What I'm trying to say here.
Yes, sir, getting, sir.
So similarly here, this unit of charge or this quanta of charge is equal to the magnitude of charge on an electron. Magnitude of charge on an electron. That is Q equals to n times E. E is the charge on an electron, that is 1.6 into 10 to the power minus 19. But recently, Hemant, we discovered about quarks, and quarks are even more smaller than the electron. Because of quarks, protons and neutrons are made up. So protons and neutrons are nothing but quarks only. Getting my point?
Yes, sir,
Three
getting.
quarks they combine, two or three quarks they combine to give us one proton or one neutron. But problem is these quarks are not stable. These are highly unstable and their isolated presence has not been detected yet. Isolated quarks have not been seen yet. They have not been observed. Okay. That's why this is the reason that we do not identify them as smallest fundamental unit of charge. We identify only electrons as the fundamental unit of charge. Got it now? Next property is charge is relativistically conserved. What do you mean by that? It means that whatever the charge is there on a body, now if that body goes with the speed of light, goes with the speed of light, then what will happen? What will happen? Its mass will decrease. Sorry, its mass will increase. Anybody which starts moving with the speed of light, its mass will increase. And this is not the case with the charge. It means if a charge is there, 2 or 3 coulomb, it is going with the speed of light, then the charge is going to remain charge. Mass is not mass, but charge will remain charge because charge is a property. So it will remain charge always. Got it now?
Sir, got it, sir.
Next is a charge at rest produces electric field. A charge in motion produces electric and magnetic field. Okay, and a charge which is accelerated, it produces light, electromagnetic radiation, which is visible to us. Getting my point?
Sir, I'm getting, sir.
Okay, write it down.
Yes, sir.
Write it down. I'm just coming from washroom. Write it down. Hello, you're done?
The copy, sir. Yes.
Copy. Now see this problem. Which of the following charges are not possible? So four charges are given to you. Okay. Here we need to use only that property. Which property? Property of quantization of charge. Means
It's a
whatever
Q.
the charge is, yes, Q equals to NE. Whatever the charge is, it should be completely divisible by the charge on an electron. If not, then such a charge is not possible. Okay, any kind of charge must be completely divisible by the charge on an electron. Completely divisible. Integer should come out, because this is the properties. This is the property says. This is what the property says. Okay. So checking all the options, first option is already charge on an electron. Second option 4.8, it is giving us 3. Third option 3.2 into 10 to the power minus 20 is there. This is giving us 0.2, which is not an integer. So always remember that if the power, negative power, is greater than the charge on an electron, then such a charge is not possible. Negative power must not be greater than the charge on an electron. Okay. Now one may ask that if such is the case, if this is the case, that an electron means total charge on a body must be completely divisible by the charge on an electron, then 2 coulombs or 3 coulombs, they are not even possible, because 3 coulomb is not divisible by 1.6 into 10 to the power minus 19. Getting it or not?
It's a
So
getting, sir.
answer to this question is that charge on an electron is very, 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 very small. So if even 100 or 2 to 300 electrons are here or there, means 2 to 3 electrons, 5 lakh electrons, and 4 lakh electrons, if we left them out, then nothing is going to happen. We won't even feel that much charge, because it is very, very, very feeble charge. Getting it? So
It's a getting.
actually 2 coulombs, 3 coulombs, all of these values, they are just approximate values, not exact values. Exact values will be given by number of electrons multiplied by the charge on electrons. Got it? But 10 to the power minus 19 it is. So it is very, very, very small. Getting it now?
So I mean approximate values are this 2 coulomb, 3 coulomb like that, but actual values will be different also.
Actual values are always different, because because of quantization of charge. Got it?
Yes, sir.
Now take this question down.
The copy, sir.
Copy. Now let us come upon charging of a body. How can a body be charged? Now a body can be charged by friction, conduction, induction, photoelectric effect, thermionic emission, and field emission. Now what is charging by friction? You must have studied it already. Charging by friction is also called as triboelectric effect. What is it? Triboelectric effect. So several materials, whenever they are rubbed with some other material, they get charged. Why? Why this is happening? This is happening because the electrons, which are loosely bound, they jump off. They just break themselves off because of the energy which they are gaining due to friction. So gaining that energy, they jump off. They leave their parent body and get inside the electron deficient body, or the body in which there are less electrons. Getting my point?
So, but means we are saying that it comes from more electropositive nature element to electronegative nature element, sir. We can say
Yes,
like
yes,
that.
yes. I am coming to that. I am coming to that. I am
Yes.
coming to that. Means, see, a material is there, and that material is very, very tightly bound. Means what? Means it is keeping all of its electrons very, very tightly. It means electrons are not free to move. Okay, and a material is there in which the electrons are free to move. So whenever these two objects will be rubbed, what will happen? The electrons which are loosely bound will get inside the material where electrons are tightly bound. Always remember that. Okay. This we can understand with the help of work function. First of all, take this down up to this point.
So can you show the upper part, the types of charging methods for body? Yes. Sir, copy it, sir.
Copied.
Yes, sir, copy it, sir.
Charging by friction.
Sir, copy it.
Copied.
Sir, copy it, sir. Yes.
Fine, fine. So, now what will happen? See this diagram. When A and B, two materials are rubbed together, both of them are neutral. Okay, both of them are neutral. Let A be glass and B is silk. And when they are rubbed together, then what will happen? Then some electrons from A, means glass, will go inside B, means a silk. So silk will become negatively charged and A will become positively charged. Why it is happening? Because A has lower work function. What do you mean by work function? Work function, listen carefully, it is the energy with which the electron is bound. So if the electron is loosely bound, means work function is lower. And if the electron is tightly bound, means with larger energy electron is bound, then it is higher work function. Got it now? Lower work function and higher work function.
Yes, sir, got it, sir.
Take it down.
Sir, copy it, sir.
Copy.
Yes, sir, copy it.
Fine. Next is charging by conduction. How a body is charged by conduction? Charging by conduction happens when the two bodies are in direct contact with one another. If a charged body is there and another charged body is there, another uncharged body is there, if they both are made to contact each other, then what will happen? The charges from the charged body will flow inside the uncharged body. Higher potential to the lower potential.
Sir,
Negative charge will flow from lower to higher, but positive will flow from higher to lower. Yes?
sir, here charged body means if it is a positively charged body, sir.
No, it can be negative also.
Sir, sir, if you say that if it is negatively charged body, sir,
Uh,
sir means we can say that there are more. We have added some more number of electrons to that body. We can say no, sir.
yes, we can say that.
Positive means we have removed some electron from that body. We
Yes,
can say.
positive means we have removed the electrons. Yes.
Yes, sir. That is the charge. Sir, means charge means here electron only we should consider, sir.
Yes. In metals, only electrons can flow. Protons
Sir, means,
cannot flow. So charge means only electrons.
sir, we can say it as quarks also, sir, because we have discovered it.
What we can say?
Quarks, sir. We are discussing quarks now, sir. Like
No, no, no,
one.
no. Isolated quarks cannot exist. Isolated quarks cannot exist. Means I know that yes, electron is made up of quarks, but isolated quark is not seen yet. Okay, several of nanoseconds. That's it. That is the life of quarks.
Yes, sir.
Take it down. Draw this diagram.
Sir, copy it, sir.
Copied. Negative charge will flow from lower to higher potential.
Yes, sir, copy it, sir. Positive charge person.
Fine. Next is charging by induction. First, draw these two diagrams. Draw these two diagrams.
Sir, copy it, sir.
Copied.
Yes, sir, copy it, sir.
Now, here what is happening? Whenever I am bringing a charged body is what? This inducing rod is the charged body. Okay. Whenever I am bringing this charged body near the uncharged body or a neutral body, what will happen? Rearrangement will occur. Rearrangement of the charges will occur. Negative charges will be attracted by the positive charge of another body, and positive charges of the neutral body will be repelled. So this rearrangement is called the induction. And why this induction is happening? Because of the presence of that inducing body, charged body, which is of positive charges. Now what we will do? When we will earth this positive side, all of these positive charges will be earthed. Means they will become zero. Only negative charges will remain because of the attraction of that induced body. So what? Now when we remove the earthing, this body will be negatively charged permanently. So this is how we can charge, this is how we can charge a body by induction. This is we have written. If a charged body is brought near a neutral body, charged body will attract opposite charge. Got it?
Sir,
Write it
got
down.
it.
Here important thing is that the inducing body which we brought near, neither it gains charge nor it loses charge. Its nature will remain same. But the nature of induced charge will always be opposite to that of the inducing charge. Means if we are bringing positively charged body, if we are bringing positively charged body near the neutral body, then what will happen? Then the induced charge in the body will be negative. Got it?
Sir, got it, sir.
Fine.
I mean that induced body will have opposite charge that of the induced charge. So you can say induced body.
Yes, yes. Induced charge.
Copy it, sir.
Next is thermionic emission. What happens in thermionic emission? Whenever we heat a metal highly, what will happen? At high temperature, some electrons they gain enough energy and they leave the material's body. And when electrons leave the material's body, it will become positively charged. This is nothing but thermionic emission. Write it down fast. It is easy.
The copy it, sir. The copy it, sir.
Fine. Next is photoelectric effect. Hello, yeah, am I audible?
Sir, you're audible, sir.
Fine. Next is photoelectric effect. Similarly, what happens whenever the light is incident? Whenever the light is incident on the surface of some particular materials, then because of the light, the electrons they gain energy and they leave the material's body. This is nothing but photoelectric effect. These fleeing electrons, these running electrons, they can be captured by other instrument and we can use them to charge a battery and to conduct electricity whenever needed. So this is what solar cells do. Okay, got it? Draw this
Samir,
photoelectric effect.
Samir, these electrons came out from that metal we use for home electricity purposes in solar
Yes,
lights.
yes, home electricity purposes, and there are large plants in Gujarat. In Gujarat, there are large plants of, or we can say farms of solar energy. Means large farms are there on barren land and they just harness solar energy whenever sunlight is incident. Gujarat is rich state and hence they are affordable to that state. Done till this point?
It's a copy it, sir.
Fine. Okay, then that's all for today. We shall continue from 7:30 then.
Yes, sir. Okay, sir.
Fine.
Sir, sir,
Yes.
generally, how many classes are required for total electricity and magnetism, sir? Just for an
See, electrostatics combined will require at least 18 plus, yeah, for 22 classes. Electrostatics will require 22 classes.
yes, sir.
Means 15 classes are required for first chapter and the remaining classes, 8 or 9 classes, are required for the second chapter.
So, my second
And
chapter
then
means capacitance, we can say.
potential, electrostatic potential and capacitance. Yes.
Yes,
So
sir.
11 to 12 classes are taken by the second chapter. 15 classes are by first chapter. Wait a minute. Yes, 27 classes it is there. So after
But,
that, current electricity is there. Means current electricity 10 classes are required, at least 9 to 10 classes. This
yes,
all this I am saying along with the practice. Along with
yes,
the practice. If practice you are going to decrease, if derivations are going to decrease, then this
sir,
chapter can be
sir,
finished
we
uh,
will go as per
within.
your plan only, sir.
Fine, but uh, fine then we shall see. Okay, I'll try to complete the syllabus as fast as possible, and that is the
Yes,
reason I took this already written notes,
yes, sir.
because if I will write them down, I will take time and you will also take time.
Yes, sir.
So that's why I'm taking them. So these are I taught them to Chanakya only.
Yes, sir.
Yeah, Chanakya has not completed, but half of this chapter of Chanakya is completed.
Yes, sir.
Okay, then we shall continue our class from
7:30, sir.
7:30. Okay,
Yes, sir. Okay. Thank you, sir.
fine.
Hello, hello.